Hi, and welcome to our lesson on derivatives. Today we'll be discussing all about derivatives. So don't worry, if you know nothing about derivatives before going into this lesson, you will know way more once you're out of it. Before we start with looking at derivatives and all the different types of examples and how to find the derivative, we need to know what a derivative is. Well, a derivative is the instantaneous rate of change, the slope of a tangent on a line or a point, at a point, and a slope of a line. Now, we can see that all of these things are singular things. These are singularly found at one point. Since the instantaneous rate of change is singularly at one point, the slope of a tangent is also at a single point, and the slope of a line. So we need to know some important stuff before we actually begin. Some of the important stuff that we need to know is the derivative operator. The derivative operator is d over dx. Now, that might sound a little bit complicated, but you've seen operators all around, actually. Quite a famous example of an operator is the square root sign. When you see the square root sign, you know when you see the square root sign, you know what you have to do. You have to find the square root of whatever number's at the bottom. So for this one, it would be 2. Now, once we're done finding the square root, the operator is not the final answer, since we've already done what the operator asked us to do. It is the exact same thing with the derivative. Once we've found the derivative, we just simply take the derivative operator out, and there's your final solution. One of the best methods to find the derivative is the sum and difference method. You can use this method when you have a sum or a difference you're looking for the derivative for. In this example, we have 2 plus minus x. First, what you would do is you would put your operator in, d over dx, 2, since we're singly looking for just the 2, plus minus whichever one you're looking for, it's in the equation, and x, the single x as we're looking for. And whenever you are showing your work for the derivative, you need to make sure you express it as f prime x. That way you know, and the math knows, that you are looking for the derivative, and you found the derivative, because your final answer will be expressed as f prime x. So let's take a look at a couple of variables. So for example, if we just have a constant as the derivative, what happens? Or if it's single x? Well, it's actually very simple. If we take the derivative of a constant of any real number, we will always get the answer 0. And if we take the derivative of a single x, it will always be 1. Yet we see that this changes when constants are multiplied. For example, we have the function 3x squared. What we have to do here is we need to bring the 3 out of the function, since we're not looking for the derivative of 3, and then that 3 will be multiplied by whatever the derivative of x squared is. Lastly, we have our natural exponential, which says whenever you take the derivative of ex, you will get ex. Very simple. All right, let's start cracking some examples. So here we have 2 examples. We have fx equals 5 square root 5, and fx equals 3 plus x. Now, this first question looks pretty difficult at first, yet when we actually realize, back to our constants and a single x rule, that any real number equals 0. So, simple enough, our derivative, f prime x, equals 0. Now for this question, we have another one of our rules that we discussed above. Whenever we take the derivative of a constant or a single a, we're going to get a 0 or a 1. And here it is expressed. Very easy stuff, but I promise you it does get harder. Alright, now we're going to look at a harder example. Let's take a look at it. What we're looking for is the derivative of f of x equals x minus 3x plus square root of 20. Alright, before going any further, let's remember our basic rules. Whenever we have a single x, we remember that that's 1. So we automatically know that's going to be 1. And whenever we take the constant of any real number, we know that's going to be 0. So that really helps us continuing looking for the derivative. So as we have the solution here, we see that we multiply our operator into each of the numbers, and we take the derivatives, as we said, as we already came to know, so just by looking at the equation before doing any work, that the derivative of x was going to be 1, that the derivative of 20 was going to be 0. Yet, with the derivative of 3x, we had to take the 3 out of the derivative, as we saw before, and we took the power of a single x, which, as we know as well, is 1. So very simple, the derivative of f of x is f prime x equals 2. So, now that we've learned a couple of the basics of looking for the derivative and how to find the derivative of a function, we're going to jump into some harder stuff now. We're going to learn about the power rule. Now, the power rule seems a little complicated at first, but once you get the hang of it, it's not too hard. The notation does look a little messy, but we'll get through it as well, don't worry. So here we have f of x equals x to the power of n. N can be any real number, and when we look for the derivative, we can see that what we have to do is we need to bring the exponent that's up the number down in front of the x, and then we subtract the exponent by 1. Now this power rule will always work as long as your n does not equal 0. The reason for this is because if it were to equal 0, then x would just simply be 1, and the derivative of a constant 1 is 0. And we also see that this works with any numbers, even negative exponents and fractional exponents, as long as your n does not equal 0. So let's jump into some examples here. We see our first example is f of x equals x to the 5th. Now I was going to put the derivative operator in here, but for these little simple derivatives, I'm not going to do it because it takes up a little bit of time, and it would just make the page a little messier. So we can see here that we follow the rules. We have n, which is 5, and we bring n down in front of x, and we subtract 5 by 1, which gives us 4. Now if we do the same for this question right here, I know you guys already saw the answer, but still, we do the exact same thing. We bring the 2 down in front of the x, thus making us multiply the 3 and the 2, and leaving us with x1. That leaves us with the final answer, f prime x equals 6x. Now, a little bit of a harder one here. I keep showing you guys the answers, I'm sorry, but we're just going through the examples here. You guys won't have the answer for the test. We can see that f of x equals 4x to the third minus 5x to the fourth. So, back to our power rule. We bring the exponent down in front of the x, we subtract the exponent by 1, and that will give us our derivative. Here we've done the work. We bring the 3 down to the front, we bring the 4 down to the front, we subtract both exponents by 1, giving us 2 and 3 as the exponents, thus leaving us with the f prime x equaling 12x squared minus 20x to the third. Here we have a little bit of a harder question though. Sorry, I'm getting all messy here. This is where the part where I said this works with even exponent, with negative exponents and fractional exponents. This is why I said this, for this exact question. Now for this question, we see we have the negative exponent 4 and the fraction 1 over 2. We're going to follow the exact same rules as we had for the other two by doing this. We're going to bring the 5 to the front. We're going to bring the negative 4 down to the front, subtract it by negative 1. That will equal negative 5. I made the mistake here of writing negative 3 because I wrote it very quickly. So you want to make sure you don't make that mistake. You want to make sure you take your time when you realize you're subtracting by 1. And then finally you have 1 over 2, which gets brought down to the front. And what we do is we subtract 1 over 2 with 2 over 2, sorry, which will equal 1 over 2 negative. Here we have our final answer. F prime x equals 15x to the fourth over 2 minus 4x negative 5 minus 3 over 2x to the exponent negative 1 over 2. So, we can see whenever we're dealing with exponents, you need to use the power rule. And as long as you use the power rule and you input it in correctly, you will get the right derivative every time, no matter if it's a negative number or if it's a fraction. So don't get too scared when you see those. Now for the last part of our lesson, which will be the quotient rule. When do we use this rule? Well, for the quotient rule, we actually only use it to find the derivative of two functions that are being divided by each other. So we have rules for sum and difference, we have the power rule, and now the quotient rule is only used when you are dividing two functions. We can see the function notation here is a little bit tricky, and I have a cool little trick to memorize it. Someone told it to me, and we'll get to that in a bit. But let's look at it first. We have the derivative operator, then we have f of x over g of x, which equals g of x times the derivative of fx minus fx times the derivative of gx, all over gx squared. So a few things that we want to realize and do before we attempt this formula is that we want to remember we only use this when dividing functions. So that's the only time we're going to have to remember this hard formula, so that's not too bad. Also, I suggest finding the derivative of fx and g of x before even attempting the formula. I know it might seem easy just to find the derivative quickly in your head, but if you mess it up even by a slightly bit, or if you input too many numbers, or just anything, it's going to get you the wrong answer. So it's better to be safe than sorry and to just find the derivative on the side before actually attempting the formula. Now, remember that phrase I was talking about? Well, here you go. This phrase actually really helps me. The way I think of it is low, low, low. D high, D high, high D low, high D low, over low squared. The low term squared. So this song really helps me memorize it because I think low is a low term, D high is always the derivative of the high or the low, like high D or D low, over low squared, which is very easy to remember. So that really helps making this hard formula quite easy to remember. So let's start working on some examples. Here we have our first example. We have h of x equals 1 minus x squared over x to the power of 3 plus 1. So here I have set that this is our f function and this is our g function. So first thing you can see is that I found the derivatives. First thing, very simply found the derivatives. The derivative of 1 is 0 and the derivative of x squared is 2x. Save here, the derivative of x to the third is 3x squared. So now remembering our song, we remember high, which is low, low, D high, high, D low. Sorry about that, a little mess up there, and low squared. So we just input these numbers and then we distribute. As we've distributed, we've gotten the numbers negative 2x to the fourth, negative 2x, minus 3x squared plus 3x4. Sorry, I don't know why I say negative, it's minus. Well, it's both. Over x to the third plus 1 squared. After getting rid of some terms and simplifying the expression, we got h prime of x equals x to the fourth minus 3x squared minus 2x over x3 to the plus 1 to the power of 2. Whew, we got through that. Okay. Now, that one was a little bit messy. I didn't remember I have another example here where it's not quite as messy and you can see it very openly. Because for the test, there's going to be questions on quotient rule, the power rule, and difference in sum, and also just derivatives. So it's very good to just see these things first and then be ready for the test. So again, I know my top function is 2x squared plus 2, and my low function, g, is x to the fourth plus 3. I found the derivatives and inputted them into my function. As I distributed 4x and 4x to the third, I got 4x to the fifth plus 12x minus 5x to the fifth minus 8x to the third over x fourth plus 3 squared every time. Okay, and lastly we have the final answer, negative 4x5, because 4x5 minus 5x5 equals negative 4x5 minus 8x3 plus 12x over x4 plus 3 squared. All right, so for the last part of our lesson, we will have our check your learning section. So, very simple. What is the derivative of the function above? I'll give you a few seconds to answer the question. Alrighty. It is not C or A. The answer is B. And I have the solution here on the back if you would like to see it, and pause the screen for a quick second. Alrighty, well, that was our lesson on derivatives. Thank you very much, and I hope you feel well prepared for your test that's coming up.